Welcome back, YouTube. All the listeners, watchers out there driving at home. So I'm driving home, kind of a chilly February day, bright and sunny. And bright and sunny in February and January in Wisconsin means cold weather. So, but it's a beautiful day for a drive on my way home. So, driving home today, I wanted to talk about the importance of soils. And in our site layout class today, we talked about earth moving operations, so excavating, grading, compaction. And I always tell the students that there's money in dirt. So there's money in dirt. What does that mean? What does that mean for you as you run your construction site, or as an owner developer as you start looking at developing a site? And soils are natural. The soils are what they are on your site. You can't do a whole lot about it. You can either try and manipulate them if they're manipulatable. If they're non-structural and you need to build structural elements in those areas, you're going to have to replace or in some way improve those areas. With building foundations, sometimes we can alter our foundation systems, and instead of doing near surface footings of foundations, we go to deep foundations. But it's all dependent upon the soil, and every site has different soil. They may be similar, but they're going to be different. The money component comes in really not with the material itself. Some of your engineered fill is going to come with a price tag as you put in your base material for your parking lot or build your pad for your building. But the soil itself, just getting subgrade material, does not cost a whole lot. The expense that you are going to incur is in transport and manipulation of that soil. So if we have to dig up and recompact soils to make it stronger, or treat that soil and recompact it to give it more strength, you're gonna utilize large equipment that's expensive. You have operators that are going to be running that equipment, and then obviously the maintenance and the fuel costs that come with that equipment. If you have to remove soil from your site or bring soil in from off your site, transportation costs in the back of a dump truck, expensive. So you've got your trucking costs for hauling that material. That's where your expense is primarily. It's one of those things where you see signs for free fill or looking for free fill, and the soil might be free, but the transportation of that soil is not. So if you want a contractor to waste material on your property to fill in areas, want that fill and they're not willing to bring it to you, you're going to have to pay to have that brought to your property. One of the things that can impact this is, or your soil costs, is your site balanced or not? So we talk about having a balanced site. What's a balanced site? Well, a balanced site is when you don't have to truck any material off and you don't need to bring any material in. So the soil on your site will do everything you need it to do. There's different soil types that are out there. The two kind of groupings, you have cohesive and cohesionless soil, and both have their place and use. So sand would be considered a cohesionless soil. It doesn't bond well unless you water it, and then you'll get good compaction. It's like when you were a kid and you were building sandcastles. You gotta add some water to it to give it some form, to get it to do what you want it to do. Cohesive soils, most notably, would be a clay. And clays are great building materials. They're much more sensitive to moisture, though, and the window of optimal moisture content to get maximum compaction is a lot tighter. And depending upon the type of clay that you have will depend on how little or how much it reacts to that soil. And you can see quite a bit of fluctuation in both the how malleable it is, or how well you're going to be able to compact it, as well as the strength of that material. So going back to the balanced site, that would be ideal. when we talk about having a balanced site, you have to consider shrink and swell. So again, throwing some terminology at you. What is shrink and swell, and why is it so important? In its most simplest form, you're on your job site, or you're at your source for your soil that you're going to be using. It's if it's on your site, we call it in situ soils, which means it's native soil that's in place. Mother Nature put it there, and we're going to dig it up. So that's what we call the bank condition. So bank condition's how you get it. You're going to now start excavating and grading. So I put a shovel on the ground and I start digging it up. So I break up the soil and I add air to it. So I'm essentially making it fluffy. That's how I explain it to my students, is you're making fluffy soil. So you're adding air to it. So it has more volume to it. So you still have the same density of material, but now you've added air to it. And then you're going to move it. So moving fluffy soil, that soil takes up more volume as you transport it around your site or transport it to the site. So in some cases, your soil might swell 10, 15, 20, 30% as you dig it up. And now you're going to take it over to the hole that you need to fill on your site. And we take it now into a compacted state. And compacted state is where we're going to mechanically compact the air out of it. So we're going to manipulate it to get it to its optimum condition of strength. And in doing so, a lot of times mechanically you can compact that soil beyond what its in situ state, what bank state was. So what originally started out as a cubic yard will grow. So let's say you're on a simple volumetric calculation. Let's say that you have 100 cubic yards that you're going to excavate. So I start out with 100 cubic yards in the ground. I fluff it up, and let's say it's got a swell factor of 30%. So now I'm actually, by volume, having to transport 130 cubic yards because it's fluffed up 30%. I then take it over to the hole that I need to fill in, and I'm going to compact it. And I'm going to take it, so now I've taken it from the bank state, which was 100, to the swell state, or the loose state, which is swollen to 100, that's the 130 cubic yards. And now I'm going to place it in my hole, and I'm going to mechanically compact it. And if the compacted condition, a lot of times will be less than the bank state. So let's say, for argument's sake, we take it to, it's got 90%. So we're 90% of the original volume. So that 100 cubic yards that was 130 in the back of the truck is now 90 cubic yards in the hole. And I need to find 10 more cubic yards compacted to make that happen. So now I'm going to transport in more material. And again, because of the swell factor, now I'm not just obtaining 10 cubic yards in the back of my dump truck. I need 13 cubic yards to now compact down to 10. So it's a science, and each soil is going to be a little bit different. And sometimes when you're looking at the plans and it's just lines on the paper or lines in your model, volume is equal for not only bank but then compacted. And if you don't take into consideration your shrink swell factor, you may be shorting yourself material where you're going to have to buy more. So understand that these expenses start to grow by how we manipulate it and what we do with it. The final thing is really what type of soils that you have and what they're used for on the site. And if I don't have structural material, silts and loams have a lot of organics. They're very fine grained material. They're not good structural soil. And if that's in an area where I want to put my building, I'm going to have to move that and put in structural material or alter my foundations as a result of that. So there's going to be an expense with that. And sometimes it's one of those things where, well, is it less expensive to alter the foundation design? Perhaps it's just widening the footing. So it's close, but we're not there. And a little bit extra concrete will save you money on your over excavation costs, so that we form it up. Concrete, relatively speaking, to widen the footing is far less expensive sometimes than over excavating and importing and recompacting material. So that can be a solution. We need to think about what happens in our stormwater ponds, and what kind of pond are you going to have on your site. So the last episode I talked about water is bad, and I kind of talked about different pond systems. And if I have a dry pond, that means I have to have a soil that drains. And sandy soil is going to do very well for a detention pond, and a cohesive soil like clay is going to do well for a retention pond where I'm holding back water. So pond area selection and soil type, we may be having to alter our stormwater design as a result of the soil, which could cause for other excavation or over excavation and placement. The list goes on and on. So the bottom line is anytime we're moving and manipulating soil, it costs us money. And as you get into that, my tip to you, if you're a developer or a general contractor and you're trying to kind of control your costs as you run into things that you may not have anticipated from a soil perspective, in your contract you want to lock in a per cubic yard rate for replacement of material, import of material, export of material. So what you want to do is lock that in, so that when your contractor comes back, your earth moving contractor comes back to charge you more, you know exactly how much you're going to pay. That's generally done on a cubic yard basis. So you've got so many dollars per cubic yard. That's built into your contract. What you want to do is, when you're doing that, because it's by volume, when I worked on the developer side, a lot of times if we had large volumes like this, we'd have someone checking load counts. So they're actually verifying the quantity of material that's being exchanged or imported or exported, so that we don't get overcharged for that. Because contractors, sometimes it's hard to justify, right? If I cut a change order for an extra 50 2x4s, it's pretty easy to see what that is. But if it's soil, I don't know. The last thing with that is when you put that number in, you want to make sure that you tag that as in place. So that's compacted final. So shrink swell, right? I don't care what it was like when you got it. I don't care how many yards it was when you transported it or how many truckloads it took. All I care about is the hole that was filled and how big that hole was, and that's what I'm paying for. The final thing with that is, why do you put in cubic yards? Contractors sometimes will want to charge you, if they're manipulating extra soil, they'll want to charge you runtime on their equipment, and that can get dangerous. And I shouldn't say use the word dangerous, but prices could come in not exactly where you want it to be. So run hours on equipment are monitored by the engine running. And so to put this into perspective, if you're going to pay run hours, think about an operator that shows up on the job site. So maybe we start work at 7 a.m. That operator shows up at 6:30. They fire up that big diesel cat. They want to get that engine nice and warm. Maybe it's a hot day and they want to get that air conditioning going, or it's a cold day and they want to get the heat going in the cab. So they're running that piece of equipment for 30 minutes and it's not doing anything. Comes break time, your operator takes a break. They don't leave the cab because it's cold out or it's hot out. They don't shut down their equipment, and it runs through break time. Same thing happens at lunch. And then we get to the end of the day, equipment gets parked, it's kind of staged, everybody's standing around talking, and that equipment might not get turned off right away. So you may have only 6 hours or 7 hours of production, but you may be paying for 8 or 9 run hours on that equipment. So again, be careful when you go down that path as well, as far as how you're getting billed for that. My suggestion to you, lock in that price per cubic yard in place up front, so you know what you are actually going to be paying for is what you're getting, and not paying for extra. And I'm not saying that contractors use change orders as profit centers. There's a lot of honest contractors out there, but there are some that try and manipulate the system to try and get a little extra cash in their pocket. And I don't condone that action. And as a consumer, you want to pay for what you're getting, not for how they think you should be getting it. That's I guess I ran a little long on this one, but I really wanted to make sure I hit some of the high points with that. So just remember, there's money in dirt. Costs can be very minimal on your job site, but can escalate at a rather rapid rate if you're not paying attention to what's going on. So driving home the fact that there's money in dirt, pay attention to your soils, pay attention to your site contractor, know what you're getting, verify everything that's being done out in the field, and you should be pretty good to go. So again, thanks for listening, and we'll see you next trip.